Hey everyone. Today, we're going to pull back the curtain on the architecture that lets AI apps on your desktop talk to, well, pretty much the entire world of data and tools out there. So let's dive right in. Have you ever really stopped to wonder how an app like Claude, or heck, even your code editor, can pull info from your local files 1 second and then connect to a cloud service like Sentry the next? How does it manage all those different conversations at once without tripping over its own feet?
Well, the secret sauce is this really elegant piece of design called MCP, which stands for the Model Context Protocol. Think of it as the official rulebook for making all these connections, and we're about to see just how powerful it is. Okay, so at its heart, MCP uses a pattern that probably feels super familiar to any developers watching, the classic client-server model. But, and this is important, it adds its own little twist with three very specific players that make the whole system work so smoothly. First up, we've got the MCP Host. This is the brain of the whole operation. It's the main app itself, like VS Code or Claude Desktop. The host is basically the conductor of the orchestra, deciding what information it needs and then setting up all the connections to go and get it. Then, of course, you have the MCP Server. This is your source of truth. It's the program that's actually holding the context, so the data, the files, whatever functionality the host wants to tap into. It's just out there waiting for someone to connect. And now for the real linchpin of the whole system, the MCP Client. Now, this isn't some separate app you install. No, it's a special little component that the host creates for one and only one job: to keep a direct, dedicated line open to a single server. It's just like having a private phone line. So, how does the host keep all this from becoming a huge mess? Well, the main rule is beautifully simple. For every single server the host needs to talk to, it spins up a brand new, totally dedicated client. That word dedicated is everything here. We're not talking about a shared party line where signals can get crossed. Nope. This is a private one-to-one link. And why does that matter so much? Well, it isolates everything. If one connection has a problem, it doesn't take down the others. It keeps the whole system clean, logical, and really robust. Let's make this super concrete with a VS Code example. Imagine VS Code, our host, needs to check for some error data from Sentry. So what does it do? It spins up MCP Client number 1, and its entire life's purpose is to talk to that Sentry server. A second later, you go to open a file from your hard drive. The host then creates a second, completely separate client, MCP Client number 2, just to talk to your local file system server. 2 servers, 2 dedicated clients. It's that simple. You might have noticed we just mentioned a cloud service and a local file system. And that brings us to another really cool part of MCP. The servers themselves can be in totally different places, but the host talks to them in the exact same way. So let's break that down. A local server, like the one for your file system, is running right there on your machine. It uses something called STDIO for transport, a really direct one-on-one connection. But a remote server, like Sentry's, is living out in the cloud, talking over streamable HTTP, and it's built to handle connections from thousands of different clients. The real magic here is that from the host's point of view, it doesn't have to care about any of that underlying complexity. It just works. All right, so we've met all the players, we know the rules of the game. Now let's put it all together and actually see this architecture in action. So it all begins here with our MCP host. This is our central hub, our AI application that needs to reach out into the world and grab information to do its job. Now, for every single tool or data source it wants to connect to, the host fires up a brand new client. You need to connect to 4 different things? You get 4 different clients, each one ready for its specific mission. And finally, each one of those clients makes its own private one-to-one connection to its specific server. It doesn't matter if that server is local or remote. What you're left with is this beautiful pattern that is incredibly consistent, clean, and just super organized. So why should you care about this? What makes this architecture so good? Well, it's all about being modular. The AI app is totally separated from its data sources. This means it's super scalable. If you want to add a new tool, you just spin up a new client and point it to a new server. And it's incredibly flexible because the protocol doesn't care if it tools on your hard drive or halfway across the world in a data center. So look, this architecture isn't just some abstract idea. It's a real-world pattern for connecting AI to basically any data source you can dream up. Now that you see how it works, it makes you wonder, what's the first tool you'd want to connect to your AI?